Okay. That's out the attendance sheet. Today, we're going to go. Oh, sure. Today, we're going to go over Chapter 21 and do a worksheet. Then after class, anytime this week, before Friday, you can take your exam. Last day to take it should be Friday. That way you don't have to worry about it over the weekend. I'm so nice. I want to give out these hard hats because you have to wear a hard hat on our field trip Wednesday. So you can't keep them. If you have one already, you're welcome to bring it. But do you have one?
I do, but it's not here.
Okay. Hope we have enough. Don't break them. Man. You can adjust them, I think, but you can do that before Wednesday. So I have before we get started on the lecture, here is yes.
The field trip is on Wednesday, right?
Yes.
You guys show up here?
No, you show up there. I'll go over this instruction sheet. If you come here, you'll be late. This is online too if you lose your paper. So you need to be at the site at 9 a.m., which is the start of our class time. It takes 25 minutes from here to get there, so if you live near here, budget that time. It's on the island. You take SPID out to the island after the bridge. You go to the second light, which is Whitecap. You turn right on Whitecap. Then you turn left on Gypsy, which is just a short way. Then left on Cutlass. There's a little bridge, you go over there, turn right on Escapade, and it'll be down about 2 blocks on the left. You'll see a house with a brown sign that says Newcastle Homes and a blue and white sign that says JMC Architecture. This is a teeny tiny map that shows it, but maybe you can see it better online. If you Google or if you go to MapQuest, you can probably see the streets better. So we're visiting a house under construction by Newcastle Homes, designed by JMC Architecture. John Pope, the owner of Newcastle Homes, will give us the tour. It's a wood frame construction home. You'll be able to see components that go into the wood frame building. This is especially good if any of you are doing that for your final project. It'll have to be like tornadoes for us to cancel, but you know, make sure you monitor your email because I would send out a notice or Canvas. I'll send it out on Canvas, I guess, if for some reason we have to cancel.
Do you know the exact address?
You know, I thought I did, but I didn't put it on here, did I? Trying to think where I can. Let me see if it's still on my phone a second. Escapade's not that long. I might have to look it up and put it on Canvas. Man, I got a lot of emails. Hold on. Okay, it's 15634 Escapade. 15634 Escapade.
How do you spell
Escapade.
That's the what?
That's the street name. If you wanted to map quest it to see exactly where it is. Corpus Christi 78418 is the zip. Okay,
And what's the 15634?
that's this house number.
Okay. 78418?
Mm-hmm. That's where we're going to meet. And we might, if we have time, go to a second home, but we'll just follow each other. It'll be in the same neighborhood.
Is it like a community area?
It's just the island. There's existing homes and new homes. So, but this is a new home going up. But there's lots of new homes going up out there right now because of Schlitterbahn. So, anyway, so if something happens and we have to change plans, I'll announce it on Canvas. You must wear, especially for the girls, you must wear closed-toe flat shoes. No sandals, no open toes, no flip-flops for anybody. Because it is a construction site. You need to dress for the weather because we'll be outside. It says I'll bring hard hats from school, but I already gave you some. So I'll bring hard hats for those online students.
What, boots, cowboy boots?
Tennis shoes or boots is fine. Just closed toe flat. No spiked heels or anything like that. Okay, there's a field report form attached to this. You need to bring it with you. This and read over it before there because you'll want to look. I want you to answer the questions on this field report. Any of them that pertain to this project, maybe not all of them do, but that'll be due at our next class period for you to answer all these questions if they pertain. Most of it, I think. But I mean, so the point is, you need to be looking and learning and understanding, not just. So, okay, is there any questions on this? So we'll meet there at 9 o'clock Wednesday morning. And then y'all can carpool, do whatever you want. Just be there. Don't be square. Okay. So now on to our lecture. Let's see. We're going to go over chapter 21, which is aluminum extrusions. We're still talking about window walls, curtain walls, window systems, stuff like that. So that's why this chapter's in here. Extrusions means what? You squeeze it out of the tube like a toothpaste. So these aluminum extrusions are frames for window systems that are extruded out of a die or a tube into these shapes. So that's what we're talking about. Curtain walls, remember, are walls that basically fall like a curtain over the structure of the building. They protect from the weather. They're a rain screen. They provide the barrier from the outside to the inside. Aluminum is a very good material because it resists corrosion, can have a variety of finishes, and you can fabricate it into elaborate designs. So this talks about extrusion production. Like I said, you squeeze it out of a tube. Here you can see them putting the heated aluminum in there, and it's going to come out in this L-shaped form. So that's pretty basic how it's made, and that can be a very complicated structure if you want it to be. Hundreds of extrusions are available. I won't read through all of this. You can do that on your own time. Connection but how do you connect the shapes? You have to have screw ports that are part of the extrusion. Self-tapping screws are driven through the screw ports to fasten the extruded aluminum shear block to a vertical mullions, and they got a picture of that on how it's done there. Other ways to connect, screw slots. You can see how this piece is connected here. The screw goes into there and then it becomes a unit. You have to have these different pieces to cover up parts. You know, you can't just put it all in there as a block because you have to be able to install the glass, and parts of it you want concealed, etc. So there's you can also have snap-on features as shown in the bottom picture. Thermal brakes, we talked about that last week. Thermal brakes are the internal components, or that's like a rubber or a synthetic material that stops the cold and the hot from getting through to the inside. And that's a pretty good picture of how that works right there. You got ice on the outside and you got your thermal brake, which stops the conduction, and then you got your inside piece. Here's a picture of a thermal brake in this aluminum extrusion. That's a good cutaway. You can see how it works. This is the outside. There's your thermal brake. This is the inside. Here's your glass, how that snaps into there. Surface finishes. Aluminum doesn't corrode, but does sometimes form an oxide film. And you can also do different colors. You can coat it with organic coatings, powder coatings, baked enamel finishes. There's a wide range of surface effects possible with aluminum. Here's a storefront system that's aluminum. That's a typical, you know, how you would normally think of aluminum, kind of that grayish silver color. Storefront meaning you got your structure of your building in this brick and concrete, and then the storefront is not part of the structure. It's just the glazing component that fills in this hole and makes your storefront. Aluminum and glass framing systems. A lot of times you see them on entrances, and again we talk about storefronts right here, and curtain walls, meaning like the skin of a high-rise building. So how do you put them together? You can study these diagrams. I would recommend that. But the principal components are metal mullions, rectangular pieces of glass, rectangular spandrels. Spandrels are the glass panels that you cannot see through. So if you look at this talks about them all. One is the anchor. That's the clip that you fasten the framing pieces to. Number 2 is the mullion. That's a long vertical piece. Number 3 is a horizontal rail right there on the inside. Number 4 is a spandrel panel. Remember, it looks like glass, but you can't see through it. 6 is the vision glass. It's obviously see-through. I skipped one. 5 is a horizontal rail. 6 is a vision glass. 7 is the interior mullion trim. So you put your glass in, then you'd snap your trim on top of that. And then there's other variations. You can also install it as a unit. You know, these pieces would come to the site already assembled, so there's less work on the site. But then you have to, you know, you have your bracket there. You have to snap them and attach them into place. This is a unit and mullion systems. Mullions and units are shipped separately. It's sort of a hybrid. It's sort of put together off-site, and then, you know, it's kind of a mix between the previous two. Panel system again. This might be a homogeneous, it's called, sheet of metal stamped into this configuration. This is efficient if you have a lot of them on like a high-rise building, because they can do that prefabricated, ship it to the site, snap it into place. Here's a column cover and spandrel system, so you don't necessarily, you see your structure behind, you don't necessarily want to see that. So they make column covers that snap into place, and then the spandrel glass that snaps over that, and then the vision glass. Here's an outside glazed curtain wall system, meaning that you put the glass on from the outside. And it talks about the different pieces you'll need to understand. Vertical mullions. Number 1, 2 is the horizontal mullion right there. 3 is the shear block right here. That's this number 2 slides into that shear, meaning so it won't slide up and down on the frame. So that attaches to the frame, then this slides onto that. Then number 4 is the glazing gaskets. That's what's going to hold the glass into place. Number 5 is the pressure plates. So this plate is, this plate goes on and then you snap that on top of it to cover that up. This is the structure piece and this is the cosmetic piece. And then 7 is a molded rubber plug that's used. That's just one type of system. Here's another a view of a outside glazed wall system. And these are showing you the different details at each different part. If you worked in an office, you would probably have to draw these details specific to your job. So you can study this. 9 right here, for instance, is looking down where this framing system butts into the structure. So you can see the sealant, the frame, the glass, the outside stuff. 9A is another variation of that that may be on the same building. 6 would be the sill down here. 5 would be the top part of that glass, how it connects to the spandrel. 4 would be the next floor up, right there. 3 would be the part, the mullion right here, where the see that little dashed line means that that window opens up. So this would be a different detail over here. 2 would be the head of that into the spandrel, and 1 would be into the structure above. 7 is a view right here of the vertical mullion. And where's 8? Oh, 8 is right here, where at the operable window. So you could draw all these if you wanted, if you need extra credit. Remember, you get 5 points each if you draw them and label them. This is a little bit more detail on that. Probably be a better detail to copy since it's bigger. Has dimensions. Talks about the different pieces again. You can study. Broken, one thing that we see here, the broken lines would indicate if you have a shorter piece that might be available in that same style. So that's where that dimension would be. Here's another, the horizontal mullion detail. And you can see on your glass, your vision glass is usually 2 panels, and the spandrel is usually 1. This is a different type of glass. And it shows you the rubber setting blocks right here. And that, you put the glass in and then you snap these into place, so then it's all, it performs a seal. Let's see. These even have weep holes. Remember, on brick walls we have to have weep holes. Well, you have to have a way for the moisture to get out as well here. So they talk, you know, every building has the same problems no matter what you build it with. So there's also inside glazed curtain wall systems, meaning the glass, if you look on this one, the glass is put on the outside. So you would put this in, you put the glass on, and then you'd snap on that cover on the outside. Inside is, as it implies, the opposite. You still have similar parts. As you see here, you've got the vertical mullions, the horizontal mullions, the shear block, the glazing gaskets, pressure plates, snap-on cover, and bottom half extrusion. And here's a similar diagram of how it's detailed. Same situation, but it's an inside glazed system. So you have, again, your basic shape. Your broken lines indicate where it could be shorter. The thermal break, number 3, is right here. And then the removable gaskets, number 4, that's the key for the inside because you put those in last. You put your glass in and then you put those in. And number 5, the glazing pockets of a different depth, etc. So if you remember this view, let me go back to that other one. Let's see. It doesn't call them removable, but that's the difference. So here these would come out, these would go in last. So you put your glass in, you snap these on, and then you put this plate on for the outside one. Back to this one. You do it from the inside. Here's a horizontal mullion detail. Again, you could draw all of these and label them and dimension them for me to get a better understanding, because some of you do need some extra credit. I'm just saying. Here's a good picture of how it's demonstrated when you do the inside. Because you put your frame up, put your glass in, you snap it down, and then you put your gasket in there. Here's a building system that's using an inside glazed system. So we got the rain screen principle. Remember we talked about rain screen last week, how it basically keeps the moisture out of the building. So this talks about during a wind-driven rain, gravity and capillary action would be likely to draw some water past the outer gasket. If the water has leaked in along the vertical edge, it will fall by gravity to the bottom where it drains out. If water accumulates in the horizontal mullion, it is prevented from running out the ends by plugs shown earlier. We saw the plugs in one of those other details. Its only recourse is to drain through the weep holes in the pressure plate and the snap-on cover. That's shown here on number 1. So the water would, the only way out, and it will find a way out, is to do this. Number 2 says external gaskets serve only as a deterrent seal, essentially a rain screen. Number 3, internal gaskets serve as the air barrier. So the external gaskets are the rain screen and the internal gaskets are the air barrier. And number 4 is hollow spaces are pressure equalization chambers. So we had all those components last week when we talked about this, and this is how it works in this different type of system. So this is just a funky building showing a sheet metal rain screen cladding system. It's keeping the moisture out basically. It's doing its job. So you also have to have expansion joints in metal and glass walls, just like you do in brick and wood and whatever. Some vertical mullions are attached to the edges of the building's floor with an angle anchor. Oval slots allow for adjustments to accommodate construction tolerances, because nothing is ever perfect, so you've got to give yourself some wiggle room. That's why these slots are a little bit bigger. And then sections of the vertical mullions are spliced with aluminum internal spline, showed with the dotted lines. So these vertical mullions slide over this spline that's inside of there. That allows for some adjustment too. And it's free to slide to accommodate any vertical movement and still keep the wind and rain and stuff out. So there's also slope glazing. Slope glazing with aluminum systems. Of course, when you put water or when you put windows on a roof or any kind of glazing, the primary concern is leakage. How will you keep that water out? So there's an internal drainage system shown here, because the water will pound through there and get down in here. So the water will find its way into this gutter, and there'll be holes further down for it to fall out. There's also got to be structural considerations. This is a rafter as well as the gutter, and you got the term purlin, which is another structural member. You've got the thermal break here. So okay, that's a short slideshow. Okay, so we have an aluminum extrusion exercise we're going to work on. Remember also, you got a lot to do, I guess. You got a test this week. You got to work on your final project because your draft is due Monday, November 25th, which is a week from today. You should have been working on it all along. I just want to see evidence that you're working on it. It's not going to be final, I realize that. It's a good time to ask me questions on it. You know, are you doing this right or wrong? Because some of you may, need to have a good score on that. And then your exam on Canvas. I said here the exam was due Monday the 25th. Do you want me to change that? Or on the exam, I put it Friday. I mean, technically it's by Monday. You can still take it over the weekend, but I just like it on Friday. I didn't cut it off. So now I'm going to hand out this aluminum extrusion exercise that you can work on together with partners if you want, or you can be by yourself if you're a loner. Everybody get the sign-in sheet?
Can I get one from Marshall too?
Yeah. Some of these are kind of faded out. Sorry. You might be able to print it from Canvas better. Okay. I'm running low on toner. It's on. Let me see what it says. Yeah, just let me see yours a second. All it says is, you can look at it on Canvas. This is a full-scale section of an extruded aluminum curtain wall vertical mullion. Name and explain the function of each of the lettered parts. So we looked at those details, and so you just, A is what does it do, so forth. I'll go back to that slide if I can find it. But you also need to look in your book. So that's a vertical, what does it say, vertical? Aluminum extrusion. Does that look like it, pretty much? That's inside and outside glazed. It looks pretty good. Okay, let's pause this.